Today, Jason and I are going to talk to you some about how university, myself through UT Extension, and private industry, Jason through plant crop protection production services, our consultant, are coming together to do work with pivot irrigation to help row crop producers in Tennessee. And some of you might wonder why we would pick pivots. Well, in Tennessee, 95% of the row crop irrigation, I would say, is center pivots. So that makes sense for us to put some time into that. I think I know about everybody here except...
I'm Diane Jenkins.
Jenkins, okay.
Jenkins Consulting.
Okay. I've met you before with your husband. Yes, I'm sorry, I've forgotten. So I think a lot of you are familiar with center pivots. Maybe just a little background. Again, it's anchored in the center point. You keep adding sections about 200 feet with the tower and tires, and the outside tower and motor guides the speed as it goes around the circle. And you can see a picture there of it dropping water with some drop sprays. I guess the thing to realize economically, each time you add a section on a circle, right, or every 200 feet you add, it's about the same cost, but there's a lot more area in that part of the circle each time you go out. So for cost effectiveness, the bigger you get, the better. And it's better not to do a half circle where you pay for the same amount as you would have, but half the acres of a full circle. But you can only take that so far because the same thing happens. As you go out and add a section, each time you add a section, you got to put more water out because it's covering more area. And you get into it with something, even with sprinklers, you get this runoff problem you can see in the bottom picture. So what ends up happening, we need to, even in our flat bottom ground, people are running just each revolution about a half an inch to 7/10 of an inch. If we get up in our hill ground, it can be a 1/4 inch to only 4/10 of an inch. So it's high frequency irrigation going around 3 to 5 times a week. And in some ways, I really think that fits better into a humid region with lots of rainfall because you can get the whole field irrigated fast. A couple times it starts raining again, you stop. And you never get these big differences in irrigation across the field. So it manages well. One problem I think we get is we're getting more, in a rainy region, we're getting more water on the crop than we would with just rainfall. So you've got more moisture, more disease potential problems there. It's fairly automated. You go out and hit and butt it, and it goes around, and you can have it stop or just keep going around. So not a lot of labor to operate it. Energy can be low. You think about maybe furrow and drip being cheaper, but if you're using drop sprays like you see there, 8 psi, you don't have to go through a filter. And your water table, especially in the along the Mississippi, is pretty close to the ground, maybe 50, 70 feet. You could put on 6 inches and maybe be around a little over $20 for the year. So it can be fairly cheap. It can be more expensive too. So maintenance is not too hard. You could comment on that, but it's not that expensive. It's all above ground where you can get to it and work with it. And there's potential to fertigate and chemigate, so you can do some other jobs with it. And then the efficiency can be pretty good. It can be up to 85% of the water you put on gets where you want it and is effective. Again, if you make poor decisions or a poor uniformity, you don't get that much out of it. And I just point out that makes whoops, what did I do? Sorry, wrong button. That makes a big difference here when we say you think it'd be cheaper to do furrow irrigation, but if you have to put twice as much water on with furrow irrigation than you do with pivots, potentially you may be having a lower energy bill with a pivot. It's possible. So anyway, that's just a little bit of background. One of the things center pivots can do is we think of them as just putting water on a whole field at one time, but most of them are coming with panels now that can at least do 8 to 9 zones, pie-shaped zones. In other words, you could do a windshield wiper in here and just irrigate this for a while, or you could slow it down in here and speed it up in here, putting more water and less here. So we can do that pretty easily. Or we can do section control with pulsing sprinklers up and down the whole lateral, and we can do all kinds of different irrigation to match a soil. And I think here, if we're looking at 2 soil types in this field, again, even we have to make a decision here. We have to say, well, which do I really irrigate to optimize? Can I just do one thing and it's good for both? Should I favor one over the other? Should I do something, make irrigation decisions that's between these 2 soils? And I think that's a place where the university has something to offer. We can really put trials together with controls, and we can get at the answers to some of those questions, which is really the same question you get at here. Maybe obvious, we might just split this out and do this separate from this, but we still have to make a decision here where it's about 60-40 of one soil and another. What are we going to do there? So that's the kind of thing I think we can do. I'm going to get Jason started now. I think where they have some advantages, they're working with the whole production surface, production of the crop, so they're integrating irrigation into that as more as a whole. So I'll let him tell a little bit about what he does.
Thank you, Brian. I started doing this 3 years ago, and I asked the grower, how did he know when it began irrigating? Half of them said because my neighbor did, and the other half said it looked dry. So, my company, we come up with some irrigation management objectives. Basically, increase efficiency because coming out of riding by a ditch, there's water flowing out of the ditches, out of the field. Most of them start too soon. When you start, when you end, and another great thing about a pivot is you can fertigate with it. Most of the time we're putting out liquid nitrogen, and we're also pulling tissue tests as well so we can fix the micro nutrients as well, and macro. What I do in the field, I keep up with rainfall, soil moisture, growth stage. Another big thing I do is pull tissue samples every 2 weeks, starting at V4 corn. Some of my fields I use watermark sensors, and some of them I use AquaSpy. The main reason I use watermarks is some fields I have beach sand to Sharpie clay in. Several different soil types, so I need 8, 9 sensors most of the time in one field, and I couldn't do that with AquaSpy. It wouldn't be affordable. So basically I use the watermarks, and myself or interns manually check those probes in the field. As we're doing it, we're also scouting for weeds and insects. This is a picture of a tissue sample pulled. Everything looks pretty good there. No major concern. Also, if you do pull tissue samples early when it's wet and still kind of cool, sometimes you will get low nutrient levels. As the ground starts to dry out and gets warmer, those will pick up on their own as the crop starts growing. 2 weeks later, nitrogen showed low at 29%. Nitrogen, and we put some black label zinc in it, which is a phosphorus and zinc product.
Can you back up? So this is based on like a you said every 2 weeks?
Every 2 weeks I pull tissue samples. And I stop about R2 on corn. Most of the time we don't go much past tassel without nitrogen. We wouldn't apply. Need your nutrients out there at the beginning anyway, so basically you're loaded in, it's kind of viewpoint. You can also track those through the year too. Basically see, as the corn growth stage, you can also see the nutrients changing in the crop.
So I was going to pick back up with some things that we've been doing for quite a while now at the university stations. So over 10 years ago, as I thought about getting started here, what really needed to be done, the concept of deficit irrigation was pretty strong in my mind. It's not because we're short of water, especially in Tennessee, we're not really having that many aquifer problems, but really as a way, how do we work around rainfall or work with rainfall? And so if we fully irrigate and keep the soil moisture as high as possible, every time we use it, we put it back, and a large rainfall event comes, where are we at? We don't capture that rainfall, so we don't get use of it. It runs off, could run off into a lower area and cause yield damage. And so those are some big reasons. Also, again, we're putting water on the canopy. We may want to avoid that. So if we can keep from irrigating as much as possible, we're not creating those humid conditions that could cause disease problems. And then we really want to promote reproductive growth and not necessarily vegetative growth. And that's, I think, especially could be important in something like cotton, which is perennial. So where you might be putting your resources in the wrong thing if you irrigate too soon. So as the first way of illustrating what I really mean by deficit irrigation, here's some work we've done for the last 4 years in soybeans using small plots. You see a lot of drip here, and that's not because we're promoting surface drip, it's just because we can get small plots. We're able to do 10 water treatments, 7 reps on about 1.5 acres, and test a lot of different things at one time. And so here's the things we've been testing. When to start, R1, R3, and R5 in soybeans, and then checking against a rain-fed control. And so by delaying irrigation, we're creating a deficit that we can capture and make better use of rainfall. But then also when we do decide to start, we may only put we'll start with some treatments, put 1.5 inch per week, 1.5 inch, so we can create a deficit by the amount we put on also. And then we repeat that when we start irrigating at R3 and R5. And if it rains, we don't irrigate. And if it rains 1 inch, we just turn the whole thing off. If it rains 1/2 inch, we run this for half the time. So we are adjusting for rainfall. And it is a deep silt-loam soil that is well drained we're working in. So I'm just showing you 2016 right now, but we really have had a fairly similar result for 4 years, and they've been 4 wet years for us, wetter than average. And what we've seen is we can delay irrigation. Here's an optimum yield with the minimum amount of water. In other words, we had the same yield up here, but we put 7 inches on. We could wait to R5, and we could put 2 inches on and get optimum yield. And so what's happened in all these 4 years, even though they're fairly wet, you can't always see that, that's like 56 bushels there, still a good yield, but we've had rain-fed yield has always been statistically lower, and we've can always in 4 years, we can wait to R5 to irrigate. And we've only had to put on 1 to 2 inches of water to get about a 10 to 25% yield increase. So I think we've been pretty efficient with that and showing, again, a wetter year or drier year, we might have to get on earlier. We haven't experienced that yet, so we want to keep this going a little while longer. There was one thing different about 2016. We did have a dry spot right in the middle that we hadn't had in the past 3 years. And up until that point, we've been saying, why is this working? And it had been, we've been saying, with the sensors in the ground, we've been saying, rainfall has at least been keeping one of the sensors, here's one at 6 and 18 inches, at above 100 centibars of tension. And then when we get into R5, if we don't irrigate, we get both sensors fall below that, and that's why we've been getting that little yield bump. But finally, we had a pretty good dry spell, and right before R5, we got some big rain events. So as you look at the dry land, you see, yeah, it's dropping off. It jumps up because of a lot of rainfall, never irrigated. But then to keep it at least one sensor above 100 centibars, we had to add a little bit of water here to get that optimum yield. So we were able to show that in these other growth stages, almost from R1 through R4, we dropped well below what we thought we could and still optimize yield. So that's been a new finding. Well, you could look at some of this data and say, well, you didn't lose yield by putting 7 inches on. Maybe we don't even have to worry about it. We'll just irrigate soybeans, we'll get optimum yield, and we'll worry about maybe losing a little bit of water. But I want to point out something from a producer field. This is a field where there's a drainage ditch and there's low ground, there's hill ground over here. We went into this before 2014, and what it had looked like was over here, it was good yields in this ground outside the pivot. A little better where we got some water. Good out here where we got water, and really bad out here in these corners. We go into a wet year like 2014, and you see a yield loss to actually no yield because of heavy rainfall putting too much water in this area. So if you're over irrigating and keeping things wet as possible, you get big rain events, you've helped make this area worse, okay? So we can't just say we just water your soybeans and it doesn't matter. Moving on to cotton and mixed soils. We thought, well, how do you do deficit irrigation when soils hold different amounts of water? How are you going to do that and make it work? And so we found a field at Jackson that had a cap of silt over sand at varying depths. And so some of this is like very close to the surface. Here's the silt, something like 11, 12 inches of it. Then it's all sand. Other places, it's really deep silt all the way down. And so that's shown here. This is the sandiest areas. Here's deep silt loam, and then the yellow is kind of in between. And you can see this if you look at aerials. This is just a Google Maps picture where the sandy areas are. You can see corresponds to where we've mapped it. You can see the lighter areas, less canopy where there's more sand. And if you're standing out there any time of year, you can tell where the sand is. It just affects the canopy that much. So we were able to get about 60-some plots out of, small plots out of this, doing the same similar things that we did with the soybeans with the drip. We've got some in soils that held less than 1 inch per foot and some that held about 2 inches, about 3 times the difference in water holding capacity. We had a good mix of years, 3 wet years and 2 drier years to look at. And again, we did, like I said, we did the same thing. We used drip tape to create all these different start times and different amounts we put on compared to a rain-fed control. And this is big. This is 5 years of data condensed into one slide, but I'm going to help walk us through it. Here's the result in these cotton field with this mixed soil. Here's the sandiest, here's the intermediate, and in this column is the deepest good water holding soil. Here's the individual years, but I want to start by looking at the average. And just look, if we put no water on over these 5 years, 500 pounds of lint in our sandiest soils is what we averaged, and it was 1,000 pounds in this intermediate soil and 1,400 pounds in this best soil, without a drop of water ever being added. So you can see the soil is really important to what you can expect to get. Now, when we irrigated, this one is the optimum irrigated treatment out of all those we tried. So we were able to bump this up almost 900 pounds, bump this up 500 pounds. We only bumped this one up about a little over 200. That's all we could do. And it took different amounts of water. In the sand, we needed 7. In this intermediate, we needed 3.5. And on average, we only needed a little less than 2 inches on this best soil. So again, all that makes sense. But some things I think I'd just like to point out also is in this best soil, there were three of the 5 years where we didn't need any help from irrigation to get our yields. It just holds that much water to get through those dry spells. But there was 2 years where it was really helpful. And the other thing, I don't think we have time to look at it, but always this has to be irrigated earlier at higher rates than this, or well, I'll show you what happens. We get yield loss in our better soils by over-irrigating them. So here's a kind of composition of some of that data. You can see from 0 to 8 inches, the sandy soil is still going up in yield. The silt loam has optimized at 4 inches, and then if we add more, it's gone down. So here's the question. If you have both these soils in your field, what do you do? Say you have 50-50 in the field. What should you do? How would you irrigate it?
Zones.
If you couldn't zone it, let's put that. Yeah, zoning's the first thing you might look at, so we can do it differently. If you couldn't zone it with such a way that it was hard to zone out, what would you do?
Water for the majority of what you got.
Okay, that's a pretty good answer. But you're 50-50.
Okay, I don't know. Just do whatever you want to.
Okay. Well, I should say, but anyway, since you're getting more yield increase than you're losing by putting more water on, I'm pretty sure you should, if it's 50-50, you should go with irrigating with the sand. You're going to get more overall yield. And in fact, I pushed this out with some simple linear models. It was more like you have to get down to 35% sand and 65% silt loam, where you should really switch to start irrigating the silt first, because you get more bump than you get loss.
I'll tell you what, then you call me and I'll come put some variable rate on your pivot and we'll fix you up.
It'll fix you up on that, right?
That's the field you can pay for it right there.
Right there. So yeah. So with all this knowledge we've got on station, we said we really got to get this off farm, and this is kind of happening simultaneously to what Jason's doing. So we started working with some producers, and one of the first things we like to do, sometimes it's hard to get to because it's time consuming, is we like to deep sample to 40 inches, look at every 10 inches and see what's there. Take those samples back, dry them, get moisture content, get water holding capacity, texture, all the things we can get. Now that's pretty time consuming, especially some of these fields we've done 100 samples and 4 per each location, so it's 400 samples to process. It's not that we really want to do this and think you have to, but we felt like we needed some ground truth to compare simpler methods to, so that's why we did it. And in fact, on some of our soils, like the bottom grounds, we have some methods I think that will work quite well without all that work. So here's an example. The Mississippi River is right here. These lighter areas in an aerial photograph are the sandy areas where the canopy's less. Here's areas where it's more silty and it's a solid canopy. If you look at your yield maps, those sandy areas jump out, 1, 2, 3, 1, 2, 3. If you look at EC, this is shallow, it shows up on deep too, 1, 2, 3. And then all that sampling we did, 1, 2, 3. So there they are. You can find them, even we sometimes find them with satellite images on the right times, you'll see these same patterns. So I think these are, the one thing that doesn't work very well is the soil survey map in this area. It'll show some of the areas, but they'll be off by quite a bit. Now, we're having more trouble with upland soils, and there the soil survey maps help better, along with terrain differences really are more helpful. So what did we do with this field? We looked at where we could change up how the pivot was operated, and we said, where it's sandy, let's get this area with more water early. Let's windshield wiper this, and let's windshield wiper that. And then where it's majority silt loam, we'll irrigate like it's silt loam out here. So we've done that, and this is 2016 yield data, and you can see we haven't completely erased. That would be our goal, to make this all look very uniform, but really over even this year data, you can see we've done a lot of good with irrigation compared to outside the pivots. And we put all our effort over in this pivot and thought he'd just follow along and do the same thing over here. I don't think he did, because you can see a difference, right? So, and then when we look at past year, we bumped irrigating in this area up over past years about 150 bushels compared to where we were in sand in prior years and couldn't bump the water up. So we've done some good. We'd like to do better. So again, that's a pretty simple strategy and can help, I think, help quite a bit. I'm trying to think what's the next slide. I guess we'll just find out. Oh, Jason's going to talk about some very